Good morning, good afternoon everyone, and welcome to episode 7 of this series on how to make a Web3D infinite runner game. Today, we're going to implement a basic collision system based on distances and thresholds, and we'll start mocking up some UI. Are you ready? Then let's dive in. Last time, we worked on user inputs, and we finally implemented the logic to steer our ship left and right with the arrow keys. We also talked about math interpolation and saw how to create animations using basic handmade lerp objects. Today, we're going to implement a core feature of our game, the collisions with the objects in the level. Remember that we have two types of objects, the obstacles and the bonuses. Hitting an obstacle will damage our ship. We will lose some hull integrity that will be comparable to health points. On the other hand, getting close to a bonus will have us pick it up and will increase our current score depending on the price of the bonus. To know if we are colliding with an object, we will simply compare our distance to the 3D mesh to some threshold. But we'll have to be careful to also take into account the size of the mesh itself. Okay, so we can actually define this collision threshold as a class variable at the top of our file. I'll choose a threshold of 0.2, but once again you might have to adapt this value depending on your game. And then let's go down to the check collisions method we prepared a while ago, that is empty for now. This is where we'll want to compute the distances and check them against our threshold. We already saw in a previous episode how to iterate through all of our objects. We can use the traverse method from 3.js on our dis.objectsParent variable to go through all of its hierarchy. Now we want to know whether we're colliding with this object or not. To begin with, let's define the threshold distance for collisions. This is the maximal distance our ship can be from the object for the game to consider there is a collision. And the distance will basically be half the size of the mesh plus the little offset that we define as a class variable. But note that we'll have to compute two separate variables for the x and z axis because our obstacles can have different sizes along the two axes. Now this way we get a bounding box for our object that is a bit extended to encompass a larger volume. And if the center of mass of our ship enters this zone, then we'll trigger the code for collision. Along the z-axis, we just have to check to see if the object's world z position is over the threshold z variable, because remember that negative values are in front of us and positive values are behind us, so we want to check if it's over this threshold. And along the x-axis, we have to check for the distance between the object's position and our current x translation. We can come from either the left or right, so we'll use the math.apps function to always get a positive value. So that's the absolute value. And then we'll just compare this value to our threshold x variable. So now, if we are indeed close enough to the object for a collision, we want to perform a different action depending on the object type. We'll do the same as in our update grid method and look at the type property that we stored in our user data. So if the object is an obstacle, we want to reduce the current health. Else, for bonuses, we want to increase our score. But to do all of this, we'll need to create some new variables. Let's go to our constructor and add the dis.health and dis.score variables. We'll start with 100 health points and a score of 0. Then when we spawn our bonuses, let's return the random price from the setup bonus function and add it in our user data object. This way we'll have access to this value later on when we collide with the object and we want to increase our score. Also, don't forget that we actually have to update this value when we respawn the bonus objects. So in our update grid method, when we use object pooling to reset our objects, if it's a bonus, we'll get the newly computed price from the setup bonus function and reassign it in the user data of the 3D object. Okay, and now we can finally modify the new health or score variables in our check collisions method, depending on the type of object that we hit. For now, we'll do a little console log of the updated value to see if it works. We also need to remember to respawn our objects so that it seems like the object that we've hit has been destroyed. And we'll compute the same parameters as in our update grid method and apply the proper function to perform the object pooling. So now if I run my game with the console open, as soon as I hit an object, I'll get a little debug of the updated value of either my health or my score. But using console debugs is not great and it's not really readable. So instead it would be better if we had some UI on our screen to display this kind of info. We'll dive more into this next time and actually do a proper UI. But before implementing the full thing, we can actually start today with just a draft version to introduce some concepts. So let's head over to our index.html file and add some new divs in our body tag. The info div will be the container for this UI, so the overall wrapper. And then we'll have two easy to refer to divs with IDs that are health and score. In our game class, we can now use JavaScript built-in method document.getElementsById. And this will allow us to access those DOM elements and store them in our instance. So we'll create two new variables in our constructor, the this.divHealth and this.divScore. And at that point, we can simply update the inner contents of these divs when we have a collision. So if you save your file and refresh the game, you'll see that there are some additional divs at the top of your page that regularly update as your health and score variables are updated too. To wrap this up, we can go to our index.css file and add a bit of styling to the info container to position it in absolute mode over the scene canvas. This will avoid the div pushing down the content and instead have it come as an overlay on top of it. We'll also make the text white to ensure it is clearly readable on the dark background. So save this, and you'll see that we get a simple but well-readable display of our current health and score in the top left corner. Alright, so this was a shorter episode, but today we saw how to compute simple collisions based on distances and thresholds, and we added some new variables to our game instance. We reused the hierarchy traversal method that we saw a couple of tutorials ago, and we started working on a very basic UI. In the next episode, we'll continue adding elements to our screen to display more info or show it in a prettier way. And we'll also add a little intro panel to only start running the game when we click on the Start button. I hope you enjoyed this tutorial, and I'll see you in the next one.